Start a streaming at 11:01. I hope this is working. It seems reasonable to conclude that maybe it is. I will find out soon enough, no doubt. It's going to be interesting to hear what it sounds like on playback too. I've never tried this exact situation before. Let's go over to chat window and make it appear. Very good. And make it be live chat, as I tend to allow all messages, and then we just deal with whatever happens as it happens. And I'm going to take a moment to switch over to this so that I can stop my icon here from wigging out. Just a moment. There we go. Now I can go back. Hi. It is the Monday coding stream. I have just released Density 2, which hopefully is going to work out okay for people. I've also carried a huge amount of firewood, but that's a separate issue. And oh, and one more thing. We're going to be doing compiles for the new version of Macintoshes. Had to go and do it. This is the M1 style laptop. Oh, everybody ran away as soon as seeing it. That's fine. I'll keep that around for when and or if anybody is actually here. So what we're doing here is fussing with a lot of controls, really, because I've revised everything, basically. It's so distracting having my face on the screen far away from the camera. I gotta tell you, it's super weird. Let me fix that. So there is much change in Livestream land, and I'm hoping that works out okay. Chat should be live and open. And I have an intention for what I'm going to do today with the coding. I was meaning to get into this last week, and I didn't quite do it. And the intention is I'm going to see if I can start putting together a feed-forward reverb. Hey, Daniel Shepard. Hey, Lorenzo. Now, what a feed-forward reverb is, here I will open up something on the... We'll go over to this. Felipe. And let's see now. And I fire up Xcode and open one of my old reverbs. In fact, let's open, what would be good? Let's open Reverb just in case I need to use similar code. I could do that, or I could open Matrix Verb. Maybe that might be good because Matrix Verb has controls for everything. And Reverb is simplified but has equally complicated... Oh, hello. Does that mean you can't hear my voice? Or I'm assuming you can. You're probably asking for... I don't know, something else. Let me first find what I was looking for. The way this winter has been going, I might end up being very scattered, and, you know, it is what it is. Where is M in the... There it is. So here, I'm going to bounce back to this just enough that I can see what's going on. Scooch around a little bit so that I'm on the screen correctly. Let me zoom in a little bit too. No, that was the opposite of in, that was out. Oh, it's pretty cold. It's pretty cold. We're going to be getting snow. We might be getting snow before my stream is out. And I'm going to be doing a bunch of shoveling, but it might not be as big as I thought, because it started out like, oh boy, 8 inches, and then another 2 inches, and then another 12 inches in a couple of days. And it's dialed back a little bit from that. Apparently not quite as much snow as it said it was going to be. Mind you, they're getting snow in Texas. It's definitely cold over here. Now, oh, I have one other thing that I can show you. Well, I am doing this with the new arrangement. There's a variety of new arrangements. One of them is my preamp is running straight into the Motu now. I'm not going through the board I used to use, and that means that it's probably clearer, but I also can't set it up till I clip the board. So there's some concern that it'll be harder to set levels. I was talking about that a little bit in the video that I made, because I had a clip of this sort of silly music thing that I did, and I'd really like to do more, but I'd never find time to do it. I will before the week is out. I'll use it as a decompress from something I'm going to be taking on shortly. I played a piece of music that was originally run through the Heritage Audio, the mixing board, and it was using its outputs as balanced outputs into the Motu. Now, if I try to run just Eurorack stuff directly into the Motu, what's going to happen is the levels are reasonably close to like +4 dB line inputs like the Motu has, but it's only going to put the input in on one side. It's a balanced input, and one of the sides is just going to be grounded. So I did that. And what I found was that there's probably a certain amount of poor noise performance from the cables from running it single-ended like that. And I can't push it to as high of a level. But it was also a lot clearer because I wasn't running through an entire preamp circuit to make that happen. And then I turned around and I ran the entire mix through this. And you can see that on the video for Density 2 that I just posted. I had a little demonstration where I was showing what you got. Remember how we took this apart and I showed you the circuit board and everything? I ran audio through it. And I gotta say, now I know what people were talking about. This is terrible for serious use. Probably mediocre for rock band type stuff. And miserable for like recording classical music or something like that. But running synthesizers into it, it's pretty amazing. In particular, it made the kick drum real interesting. So that was exciting. And the nice thing about it is that if I can do that and find that the behavior is super different from, I actually shot it out against what I had done with Channel 9 and openly admitted, like, yeah, here, listen to Channel 9 and listen to what this real thing is. I'm not even close. I'm not even close to doing the stuff that those old Mackies do. Like miles away. But that's good. Because if it's that obvious to me, then I can run like test things into it, and I can do stuff like tracking a kick drum and hearing what the device does and going, okay, let's take this apart again and let's look at where the signal goes. and how they build that 2-band EQ, which I think is part of the key to it, because the sound of this thing has a lot to do with basically every stage along the line is distorting. I can do distortions, but it's not going to be the same just doing a distortion as it is if I'm like modeling a multi-band EQ and distorting the individual bands, and then maybe filtering them more, who knows, but modeling, like working out what the topology of that is. And the thing is, I do have a EQ that distorts bands. It's not a 2-band EQ like that one. And it is in bass drive. So there are possible ways, like I've never done a bass drive that was 2-band like that and also let you go to the really high density settings. But I have density. And if you had like patchwork, it's Blue Cat patchwork, you could probably do splitting stuff up into frequency bands and then running either the original density or this new density 2 on those individual bands, and you'd be able to get just as much gain on those as you would on the hardware device, but not necessarily with the same slew clipping. Like I said, I have set up so that I am doing experiments, hardware experiments, and I'm going to be getting 1,000 little op-amp chips of the same basic type. Not exactly the same because it's not the same form factor. The ones in the Mackie are single inline pair, 9-pin rather than 8-pin. Lots of things are very different about it. But the basic general design and the specs, you can still get that chip. It's not quite the same, but you can still get that chip. And you could still wire up like a 2-band EQ and run a bunch of these chips into each other and sort of start clipping them a lot and building it with those chips and the right kinds of parts and so on and so forth. So I'm going to be trying to put that stuff together on a breadboard or perf board or something like that. Those are going to be other streams. I spent a fair bit of time this morning taking my old Moog casing, what the DFAM shipped in, which is a little Eurorack sized box that it doesn't come with good connectors like nuts and bolts and things unless you go buy some. So I went and bought some. And so now I have lots of nuts to install many different Eurorack devices in that little case. It's a pretty case, it's nice. And I can plug my 22 gauge wire into where the power supply goes. And I can probably plug a wire into where it goes out to the 1/4-inch output for the device. So I can use that as also a little test bed. And I spent a bunch of this morning trimming pieces of perf board. And I'm talking lots of pieces of perf board, like 10 times as many as would fit across a single DFAM or Mother 32 case. Because that's what I'm going to do. I have to drill holes in them next, and that's also going to take a while. But the idea is to jump in such a way where you're not sitting there watching me doing all of the really tedious starting bits and kind of going from there. Because I need to be able to do this in such a way that people can see what I'm doing, follow along in the circuitry building, and see it in a way that you can see that this is something you'd be able to do too. That's the goal anyhow. But to return to, well, firstly, let me again return to OBS and check that everything is still broadcasting. I assume people are hearing me, otherwise you'd be yelling in chat. Like I said, I've got the preamplifier running into, I've got my little lavalier mic running into the preamplifier. That's running into the Motu. I'm on channel 13, like the Pixie song. and I've got a program called Line In that's patching that directly into either inputs or outputs 1 or 2. The important thing is that it's coming through. So I'm glad that it sounds perfect. I'm going to be using something like that for certain kinds of live streams at least. And on streams that involve me getting into Logic or alternately Reaper, because I could go back into Reaper, because that's the thing, as I've discovered recently, that the problem with new Logic not handling my audio unit plugins is not about my plugins or even the fact that I haven't compiled them for M1 processors. It's that Logic is broken for that stuff. So I'm going to have a race. I'm going to race and see who can finish first. Me porting all of my plugins to the new M1 Max and have a new AU compile built and keep the old ones because I'm still supporting installed base. Or whether they debug their problem and fix it for Logic before I finish doing that. So I'm having a little race with Apple. And when enough people are here, I can show you what, man, people are just evaporating left and right. Concurrent viewers is going crazy. This could be just me talking to myself and posterity, because I don't delete streams afterwards. I do want to wait and see whether people show up so that I can show you how I'm going to be doing this compiling. But for now, I should probably shift gears again and over to matrix verb. Oh, and one more thing. Because of the way I've got all of this set up, I have now got a different way of monitoring it. Remember how I've been holding this microphone up to the tiny little speakers? Well now. I can't spell today. Matrix verb, there it is. I have my full studio rig. Including the subwoofer. So this is what it sounds like at my listening position. So there you have it. So this will make it a little more interesting to audition some of this stuff that I'm doing. Because now technically, and you're probably able to hear this very well too. Technically now I can play stuff and you're hearing the full studio mains rather than just a little tiny thing. And that's because I've got the optical out of the old laptop patched into the good converter that's driving the speakers. And that's what I'm using for output on the regular machine as well. But basically what this means is, yeah, I know, even with it, I have serious subwoofers, and I've done a couple of live streams on those. I know I did at least one, and I think I might have done one for revising them. The subwoofer is a sonotube, which is a sonotube, which is a cardboard tube. I'm actually using 2 concentric cardboard tubes. And what I've got is 4 12-inch woofers. They're not expensive. They're acoustic suspension 12-inch woofers. And on each end of the sonotube is 2 woofers facing each other. And when the signal voltage is positive, all 4 of the woofers push outwards from the tube. So it is a it's a kind of isobaric woofer design, and there's almost nothing required for the container because all it has to do is contain pressure. And a sonotube is a construction material. It's meant for casting concrete. So it will contain a pillar of concrete without breaking or exploding if you use it properly. If you get it wet, then it will leak and the concrete will break it. But it can certainly contain air just fine. So now if I have stuff to demonstrate, you can hear bass as well. Yeah, excuse me. And that ought to make the demos of plug-in things that I do more interesting. It'll be more interesting for me as well because I get to seriously monitor stuff for a change rather than having those tiny little speakers or the laptop speakers. All in all, it should be good. Oh, by the way, if we hit either 20 people watching or possibly just 10, I haven't decided, I will show you the secret weapon for me doing this recompiling and stuff, because I have taken extreme measures. Also, it's in the beginning of the stream, but so you could rewind for it. But for now, let's look at matrix verb CPP. What is a matrix? Matrix is the thing kind of like this. We've got this system here where, for starters, we were making all-pass filters, and then we're feeding 2 separate householder reverb matrices. That's 2 separate sets of 4 delays, just delays. And it says all pass this plus feedback. That's because this setup is using the 2 sets of delays and running them in parallel, so you're hearing both of them at once. And then looping the output back into the input again. In fact, it's capable of looping the output back into the input so much that it does infinite reverb. We were fooling with that a little bit earlier. That's a feedback reverb. Now what I'm going to ask is, what would you get if, oh, and let's go back to what we're actually looking at. This is what I was talking about. Householder matrix. Well, maybe somebody who is interested in programming plugins will watch them. Then maybe they'll learn how some of this stuff works. Honestly, though, I mean, I'm glad you say that, even though I'm trying to talk about the programming, because I've been taking steps towards trying to be able to do other and additional things, like come a day before too terribly long, I will be able to, for instance, do a stream and be like, I'm learning how to do animation. This is a program called Toon Boom Studio. It is a professional grade animation thing that I bought a bunch of years ago because I had cash on hand, and I thought it would be good to invest in something, and I've never really learned how to do it, so let's do it together. And the things I'll be talking about will correspond to any animation situation, even if it is something like what you do in Blender with the grease pencil tool in Blender. That said, I could also fool with Blender. Or I could get back into fooling with Minecraft, although I gotta say, these days I'm feeling like if I go back into Minecraft, I don't want anybody else there with me. I could do it. It'd probably be a little boring because I feel like if I get to the point where it's like, that's what I want to do, I'm not going to have a lot of chatter going on. But I'm probably going to want to just run it privately and not be sharing the space with people because I've been frustrated with people lately and I'm not good at people. So we'll see. For now, I'm talking about programming. That is something I have at least put a bunch of effort into, and I'll be diving deeper into it now. So here's, before yammering away for another half an hour, my idea was I wanted to experiment with a feed-forward reverb. So what I'm showing on the screen, if I'm not mistaken, I believe it is out of matrix verb. Matrix verb is this program with all of this stuff to it because it's a little big and complicated. I could have set this stuff up beforehand, but you know. And the way it works is, firstly, it's doing some all-pass filters. Those are blurring things, and I don't have to have them. I'll probably leave them out. Or indeed repurpose them because I have something in mind. And I put some spaces in here. This is the householder matrices of matrix verb. It's two of them, they're running in parallel. What that means is we're doing these delays. They're all different delays. And then we're doing these delays simultaneously. They're parallel, they're going at the same time. And they're all getting feedback. And the feedback is oriented into these groups of 4. When we go over to where it was, this is a way of doing the delay tap, and this is a way of interpolating and also calculating to what extent are we getting interpolation versus just clipping to the next available sample. That's what all of this stuff was. And this cross mod is what made the weird spring reverb or plate reverb sounding stuff. Yeah, that's why I put stuff up on GitHub, is so that people can start using these things. This is what makes a householder matrix. There's 2 of these. They're running parallel to each other. The cross mod is just feeding them into each other. The other 4 reverb tanks are just for the all passes. They're smaller, but they're all basically just delays. I've got a total of 12 little delays. And one of the householder matrices is 4 of these delays. And you see that feedback A, interpol with all of this stuff, is interpolate. And this is the output of the echo. This is the output of the delay. And this is all the complicated stuff that we set up to make that happen. But basically the end result is we put sound into one end of a delay, and the delay ran, and these, and they're not the police station interpol, they are the interpolation, is the output of whatever that delay is. See, it ends up with input sample is all of these added together divided by 8. And the householder matrix is, as you can see, this is exactly the same thing. Regen could be 1. If regeneration is cranked up all the way, you got infinite reverb and it's infinite regeneration. Or you can just leave it out and you have, built-in infinite reverb. Feedback going back into the beginning of the delay for A is the output of the delay for A, but minus the full volume of the outputs of the delay for B and C and D. All of these work like that. They all work like the output of this is the same as what we put into it. It's 100% feedback minus the full crank of everything else. And like feedback D is the delayed section of D minus the full crank of the delayed sections of everything else. And the way that matrix works is it will circulate sound through all of those different delay tanks forever without it like regenerating or favoring any particular frequency. The way it's designed, it just feeds through perfectly, doesn't start making any unpleasant noises, and then you can fade it away any way you want. And as it keeps going, you start getting more and more complicated sounds. Like the first way through, we have 4 echoes, and then they're all being fed into the input again, which are all different delay times. So each delay time coming off of the first output is being multiplied by 4. It's going back in again, and then that is coming out the end of all 4 outputs again, meaning that then it's now like 4 times 4, then it's 16 echoes the second time through, and since it's infinite delay, it's 16 times 4, and so on and so forth. So it turns into this infinite drone. And I could fire that up again just to show you. Or open one of these things. I'll open this one. Or better still, I'll open this one. It's a tick noise. And if I put that into, say, matrix verb, no damper, no filter, room size can be anything, what you get it is fading away very slightly because it's meant to be more natural than the infinite reverb. What you get from that is 4 echoes that almost instantly turn into 16, that almost instantly turn into 4 times that, and so on and so forth. They keep feeding into each other, and then they keep cycling. And it just keeps going. Or we could fire up infinity. Do I even have that in this recent effects? No, I don't. And that is also a householder matrix, a simpler 4 delay one, and it just continues. Because that's what you can do. As you keep feeding it in, the way the matrix is arranged, it doesn't matter how many times it goes, it will not start favoring any particular frequency, it'll just keep going. Here's the thing though. If we were looking at this and we went, here's our 4 thing matrix. What if we said, okay, we've got ABCD and we've got the delay tank for ABCD. That's all well and good. And then instead of feeding it back, we don't feed it back. Instead, we feed it forwards into another 4. And they don't have to be the same delay times either. What happens then? Well, we get the first echoes, and then as we go into the other 4, we get 4 times 4, not just 4 plus 4, because each input of the delay tank is going into all the other outputs, just inverted or not in various ways. And then if you have your 16, and you go from the outputs of the second wave of delay tanks into a third wave of delay tanks, what do you have then? Well, you have 64 echoes, none of which are going to be quite the same if all the different delay settings are different. And that's enough to start sounding like a reverb all by itself. And that's what Feedforward is. And remember, we're currently running 4 echoes just for doing an all-pass filter to smear stuff out a little bit, 4 echoes for one of our householder matrices, and 4 echoes for another householder matrix that's running in parallel. We're already doing 12 delay tanks just doing this. So we already have enough delay tanks just sitting here waiting to be used that we could quickly put together a feed-forward reverb that has 64 outputs without even getting into any, and that's nothing, because if we did just one more layer, 4 sets of 4 echoes, instead of getting 4 plus 4 is 8, 8 plus 8 is 16, instead of getting 16 echoes, you get 64, 256 separate echoes at full volume out of the whole rigmarole. So this is a good concept. I'm going to take a moment and step away from the mic and grab the notes I made for this. If I can find them. I bet I can find them. Give me a second. Bound to be around here. Oh, I know where I put them. I put them down here where the soldering iron is. I fear that was very loud. Sorry about that. Scraping noises literally on the microphone. So let's see. Put that here. So feed-forward householder matrices works kind of like this. You have your 4 little delays, and they're all going in parallel, and they all feed into all of the additional 4 delays, and then those all feed into all of the additional 4 delays, and you wind up with 256 echoes out of just only this many delay tanks being run, and that's a feed-forward matrix. Now, what makes that interesting is that the distribution of these can start to act really random. It doesn't sound the same as feeding back, especially if you have short delay times, but even if you're doing longer ones. It's not going to be quite the same as the feedback householder matrix. Even though that will give you infinite reverb, it does kind of sound like an old reverb box. I also thought that maybe I'd be able to do it by making arrays of arrays, like, this much delay time times 4 times 4, and you'd have just one parameter, one variable in a simply enormous array, and all of this stuff would be referring to different levels of that. Could probably be done. I was also wondering whether I could make smaller delays, like shuttle back and forth, to do a kind of pitch bend or a kind of pitch wander, and that's something I'm going to have to experiment with later. But what we probably will be able to do today before I log off is set up the feed forward thing, because all I have to do is copy over everything that I've got from Matrix Verb, perhaps commenting some stuff out, and then just steal all the reverb tanks that I've already got. I don't necessarily even have to change the way that they're getting their delay times. All I have to do is arrange them differently and have them feeding back into each other. And what I was going to do is experiment with the way this stuff is arranged, because here's the deal. if you arrange it so that the short delay times have a consistent path through the, like if like reverb tank A of each section going like A, B, C, D, A, B, C, D, A, B, C, D, 3 different sections that everything has to pass through. If section A is always a small number, even if it changes, even if it's different numbers, there's going to be a way of getting more echoes up front. There's going to be more delays initially. And then as it continues onwards, there is a smaller number that will have gone through long echoes at each stage. So there will be a long, sparse tail, rather than getting more dense like a traditional reverb algorithm will. It'll be a cluster of immediate echoes, and then sort of like one quiet one much later. If I think what I did here was I was working out if you tried to increase the delay times in this particular way, you could get a sparser tail, or if you arranged it so that the quick delays happened first, and then longer ones, and then the longest ones, you would get the most even dispersion. It would be the most sort of like an all-pass filter. And these are things we need to experiment with today. I mean, I can make notes about them, I can talk about them. I feel like kind of we need to hear them. So we're going to dive back in. And oh, by the way, I'm working on also improving the video stuff to some extent, because one of the things that's been a real challenge recently is that the ATEM mini that I use for this video switching, which I can't really do without because I got to do some of this stuff, does not reliably work. Like, it just does not reliably work. And I power it on, and sometimes OBS just doesn't see it at all. And when it does see it, I get the feeling that it's showing a 720p feed. So basically what I've done is I am going to experiment with some different style capture stuff. I'm trying a Razer little capture box. And I'm going to do what I was doing with the Thunderbolt Intensity Shuttle and run the HDMI from the switcher, which is raw HDMI, it's uncompressed, into the Razer box, which hopefully will arrive before too terribly long. And when that happens, that's supposed to, and it's not supposed, there's apparently no software to go with it for the Mac, but it's supposed to work with OBS for the Mac and be just seen as a capture device. That's really all I need. I don't need other stuff. I'll do everything in OBS, be quite happy with it. And it is said that being a gamer machine, this thing, it is said that it can take uncompressed 1080p audio, run it to the computer, and that would be an improvement, because what the ATEM is doing is usually failing to successfully run motion JPEG to the computer, just to work with it and then compress it again to send it to YouTube. So it'll use up the USB 3 bus much harder, but I don't care about that. I'm sure this will work. So I'm working on that as well. When that shows up, I'm also looking to get a little webcam-y thing so that I can start putting the other computer with stuff like Minecraft and Toon Boom and Blender into service. And we'll see. I don't know what to tell you, we'll see. But for now, today, and it's getting closer to noon, today was about trying to put together a feed-forward reverb algorithm. I'm going to crank up the speakers a little bit for next time I use them, and We're going to do new project. I'm not concerned about having it be a stereo plug because that's not really where I'm coming from with this, although it might easily become. But for starters, we're going to just do a mono, and let's call it forward verb. It'll be a sort of testbed feed-forward reverb. My feeling is that if I can put this together and get something that works real good, it will work also as a sort of early reflection kind of deal. And that might have all kinds of uses. Like, I'll not even worry about incorporating some of the things. It might be very simplified down to where it's acting like the infinity, but it'll be a feed-forward algorithm, meaning that it will produce that type of thing. And if you've never heard of feed-forward reverb, I don't blame you. Nerd patrol here. But I will note that you will run across that in the discussions of, oh God, my brain's shorting out. I can't remember the guy's name. Let's just say that a very, very expensive hardware reverb unit is handled in that way. You'll see the guy that did it, and I'm talking the Bricasti. The guy that programmed the algorithms for the Bricasti talks quite often about, like, oh, I like using a combination between this. You don't just use feedback. It's amazing how much you can get out of feed-forward algorithms and stuff. And so I'm like, aha, I think I know what's going on here. We are resynthesizing much more complicated stuff without patterns in the reverb send by designing a really interesting feed-forward algorithm and handling it properly. So that's what we're going to dive into today. We'll start by making the plugin and oh no, and quit unexpectedly. Like, let's not do that, shall we? I think I still have the, oh my God, I don't know how much chat is delayed. But yeah, well, there's tons of programming videos. The question is whether anybody is doing a feed-forward reverb programming video, or indeed doing a feed-forward programming video and then exploring what it takes to make the thing sound good. Because that's the thing. You can have all the programming videos in the world and people can teach you how to use C++ classes and stuff like that. And I've had years of frustration with folks like that not being able to make stuff actually sound good. So let's see what we can... Let's open this again. Seems to be alive now. And we're going to dive in and start making this into a working thing. mxverb, so we'll call this one frverb. Forwards verb. That's the identifier. And we're going to copy stuff out of H. Let's literally copy everything out of H. All of my windows are too large, so I'll make them smaller and move them where you can see them. I'll copy from parameters. My main purpose here is I want to get something up and running so that I can start fooling with it. Tinkering with it beyond that point is what we call refactoring. And some of the stuff I was talking about that's sort of vaguely sketched out in terms of ideas is very much part of that refactoring process. Like if I was to make this all work on a single variable, that'd be a refactor big time. But what I want is something that works. And my delay times look okay here. I already know how I'm going to go about doing this. That's been saved. And now I got to copy the stuff from the CPP file. That happens in a variety of places. For starters, up top, we now are no longer using some of these things, so these get simply deleted. I'm going to have a look and see whether I'm using just 0 to 1. I am. So I'm going to glance over here and see that from parameter 8 to 10, we're no longer using them. I'll delete those. We need to have this stuff in here for resetting everything. So I'm going to do that. Oh, missed it. I put that stuff here. And then lastly, I can just copy everything from, this is recent enough that I don't need to be concerned about not having a current noise shaping or something, or dithering to a floating point in there. I can just literally copy everything from this on down. And I'll build it and I'll run it, and that will show that I've got what I needed. And at this stage, I can close matrix verb because I have everything that was there here. It's going to take 2 builds because it's going to have lots of problems. That's because in this version of Xcode, the first time I try to build, it doesn't actually build. It needs some things that it tried to build in the first go through. And when it tries a second time, it'll be like, oh, now I know what I was doing. And it will compile that. It takes a little while because there's a lot of code in here. And here's our component. And we had just heard what the previous one sounded like. Go to the new one. I think we have matrix verb again. Now, what do we do to change it? Well, like I said, we can comment out some of these things to simplify. For instance, I can keep the dry wet, but I can comment out the version of console I have in here. I can comment out the filtering. Oh wait, this is still more filtering. I apparently have 3 layers of filtering. That's fine. Oh yeah, because that's what I'm literally doing with the filter in there. It's not just the ultrasonic filter. That's what I'm using to cut off highs. So that's one of the controls in there. Here's our outputs. Here's this and that. We get to comment out this because we're definitely not going to need it. These are going to matter later. And we're going to rearrange some of this stuff. And we're going to duplicate some of this stuff as well. And got one more, which is the pre-delay. We're going to leave that alone for now because I think we're probably still going to want a pre-delay. And this is our delay times. So if you remember, I had this little note that was about figuring out what delay times would work. We're going to be rearranging these numbers according to that little chart to get some of the things we're trying to get. Hey, it's not even noon yet. Good. Going well. We'll leave a bunch of this stuff where it was. We'll leave all of this stuff where it was. What we're going to be trying to do is take I, J, K, and L and make them into the same types of delays that A, B, C, D and E, F, G, H are, but they're going to happen first. So how shall we do this? Firstly, the way this is arranged is making it be an all-pass filter. And that's not what we want. So let's maybe firstly, let's split some of this stuff out. In fact, maybe we'll literally copy this over and change it to be I, J, K, and L. So what we'll be doing is literally deleting all of this. Boop. It exists in the previous reverb, so if I needed to go and get it, I could go and get it back. But I'm feeling kind of like I actually don't want to do that, and I also don't want to do the other reverb tanks in parallel. And I also know that I don't want to do feedback because this is going to be feed forward. Oh, got that backward. Sometimes you're just a big pile of derp and there's nothing to be done about it. So that will now start looking like how this is supposed to work. And we're going to start moving things. And let's take this out too. I think we took out our console processing, so let's take out this too. And let's take out the filter. So we got the pre-delay. We got no filter. We're starting to rearrange this. When we've successfully rearranged this into a single householder matrix reverb tank without any feedback to it, we can stack that up and start doing it over and over again. So that actually has no meaning anymore, so we'll be doing something different. However, in order to find what I'm going to be feeding into E, F, G, and H, I need to rearrange all of these. So let's start doing that now. Copy and paste it up here. That is in that sequence. I do have a vibrato thing going on, so we might as well have that also be part of this. See how every chunk of this I'm taking and moving elsewhere? I want this all to be A, B, C, D stuff up here. Strangely, it's all stacking up in such a way that there's no space. I can click here and then immediately, no, this time I gave it a space. It's doing this. And then lastly, this stuff, interpol A through D. And I'm just continuing to go through here and try to get this chunk of code to relate only to these 4 reverb tanks. In theory, I could comment out the other one and it would be just the one. But that's not what we're going to end up doing. Cross mod has no purpose to what we're doing now. And feedback is not going to be relevant, but I'm going to copy it anyway. And you know why? Because this is where I get my value for the next thing, and so on. So let's tighten this up a little bit. Space this out a little bit. This is everything I need to do to have one of these householder matrices work. And then this is everything I need to do to have the second one work. And lastly, we don't really need that, do we? There is no output for it, but we're going to take the output from I think that's how that would work, isn't it? No, maybe not. Well, I might as well leave the feedback there. It's not that I'm necessarily going to be using it. But what I was going to say is that my output is only the final 4. I'm not taking an output from the intermediate 4. This is all going through in a line now, except for that it's more like 256 lines because of the way that it all combines. And feedback E, F, G, H, I don't know. It might work to feed that back into the input again. I can worry about that later. That is something I can experiment with later. Hey, Francis. So firstly, before getting into this too hard, I'm going to take this and copy it, because I wanted the IJKL. And we feed our first thing with this. And also, what I'm now curious about is, do I have any capital A, capital B, capital C, or capital D that's not what I want to replace? Because I might be able to do a nice little search and replace in just this zone. And that would be good. That would save me more than a little bit of time. So let's see. Well, a capital F would get me in trouble, but I don't think any of the other things are going to be a problem. So let's try that. This will be much quicker. Find and replace. Let's see. IJKL. So we're going to go with A to I. Hold down Option only in the selection. It's removed my selection, which is annoying, but that's fine. I will just go back again and put more in. B goes to J. Again, hold down Option only in the selection. I wish it wouldn't take away my selection, but whatever. Compared to how slow this would be if I was doing it manually, I have no reason to complain. C goes to K. And just one more, and we might start getting to where we can make something happen audible. D goes to L. Okay, so now we're feeding these initial ones that started out being all-pass filters, but now they're being treated as just regular ones, but the time constants are still the same. But I see something. Vibe length. See, I was talking about how I was going to be careful about that. I've changed all the capital D's to L's. So now it says vibe length, and there's no such thing. So let's fix that. The error that it threw would have been pretty obvious too. camel cases when you have the capital letter in the middle of that stuff. And that's kind of what I was worried about, was having something in there that was getting changed that shouldn't have been. But now what we've got is hang on. I'm doing this wrong. Remember how we did these 4 different things? There are 4 different echoes, and they are generating interpolated things if we have pitch bend and stuff, and then feedback, what you would normally send back into the beginning of the delay again. That's what we're putting into the next stage. We're not necessarily putting it back into the beginning. We could try, but what I'm interested in now is doing this. Now, each of these new reverb tanks gets a little of all the previous reverb tanks. That's the idea. I won't even need to change time constants or anything. This will do something. Exactly what is another question, but it will do something. And here we are at the outputs of A, B, C, and D. And same deal. We're sending the output of all the combined things from the second stage into the third stage. And onwards we proceed. We might be able to do an all-passy-like thing this way too, but that says maybe. Not so concerned about that. We could do a old-school Alesis that doesn't have math version of all pass, where we do feedback A plus feedback E divided by 2. Shift the bits and do it that way. But for now, I don't even want to hear that. I just want to hear the output of the raw feed-forward algorithm. And then here's the final one. Here's feedback E. This is what would go into another stage. I do not really think that we gain anything from having the input sample be these, because they're nothing but each thing instanced 4 times, but 3 of them are negative. So this can be fed back into other reverb tanks, but I don't think that's what we want to monitor for the output. So there we are, input sample equals all of the final ones divided by 4. We're going to build, and it wasn't finding what it was looking for, so we're going to figure out whether that was still a problem, and it was. So now we've got to figure out what was different about I, J, K, and L. We've not declared these things properly. So we got to find some of this stuff, like, where did we declare those things? We need them to live here and here. The count and delay stuff is fine. This stuff is fine. And this stuff is not. So we need to actually go over into the H file, which that is not. And we're going to find this stuff where I was missing some of those things and just increase it. H, I, J, K, L. There, now if we instantiate these, meaning we're telling them what they are, we instantiate them when we start using them, like that just instantiated them, but we also need to tell them what values to be, and that's what we do here. So I'm not really quite sure where we're getting those. We'll just keep it the same. IJKL. I assume that must mean something, those hard-coded values. But for the time being, I think we're going to just have it stay at 2088. And this is going to be customized. IJKL. It'll be random each time. That's probably enough. Let's just quickly try to build it and see if it's still freaking out. And says that it's happy. Okay. No issues. Speak for yourself, computer. I am going to run it now. We'll fire up one of those Dragon's tracks. And let's see what we got. Leaving everything just as it was. That is Feedforward. Although something weird about that, I am getting not what I expected. So what's going on with that? Our output is probably fine. What input sample? Oh, I get it. We're retaining input sample. Oh, no. Wet is always there, this way of doing it. So I'm thinking maybe I'm not going to keep that. Let's go and find another project that isn't wired that way. Does density have a... Let's find out whether density has a normal dry wet. Looks like it. So just coded this one, and dry sample times 1 minus wet plus input sample times wet. That is a normal dry wet. Let's rebuild it so we can fool with this without getting taken aback by stuff working differently than what I thought it was going to do. And back into the breach, because I want to hear what this sounds like blended with dry. And I want to hear what this sounds like with just a tiny bit of it in dry. Let's make the room size huge too. And no vibratos and no damping. So we have a sort of continuous flow going on here. And we've disabled some of this stuff. We have not disabled vibrato. We have disabled flavor. I think. And this is our main delay. So the way this is arranged right now, we have almost no change between the echo, they're all working out to be very similar amounts of delay. It sounds almost all-passy, but this is not an all-pass. And if it's really short, there's almost no delay to it all. We are getting a slapback thing going on. But here's the deal. I need to experiment with the other way of arranging things. It's given me a certain amount of space, but all I need to do to rearrange how this finds its stuff is rearrange these. Delay. So maximum value will be delay times 100. Now I could rearrange the delay tanks, but I seem to have enough delay on tap to do this. What we're getting is very much this most even dispersion, most all-passy. Like instead of being 1, 2, 3, 10 or whatever, and 100 or whatever, everything is almost exactly the same delay time. Some of these could be much smaller. Like if I, J, K, and L were much smaller, then the overall delay would be much smaller. If these final ones were much longer, the overall delay would be much longer, but you always have to go through one of the really short ones, a medium one, and one of the really long ones. And we're hearing that now. Like if all the delays were literally the same delay time, it would be just like a horrible slapback echo. That's not what this is about. So the idea is arranging it so that it has more dispersion. In other words, some of these paths need to be short and some of these paths need to be longer. And the way to do that is to have, rather than here, I can probably just straight up hack this and make it work. Like, and not only that, let me move this so that it makes better sense to me. Copy, delete, paste, delete that. So what we have here, these are the first ones, these are the next ones, these are the last ones. What we need to do to make it spread out more rather than all lump at once is have the top ones be short and the bottom ones be long. Like instead of 43, you got 4.3. Instead of 79, 7.9. Instead of 61, 6.1. And then the long one, instead of being 31, like 310, or 67, 670, 47, 470. Now I can't scale it up as big as that, but what I can do is make it smaller, because I had plenty of room to adjust in there. So what we're going to do is pick stuff that's always shorter than the bottom one in the line. Let's just that noise is a truck outdoors. I don't know whether you could hear it, but I could hear it just fine. So I'm assuming the microphone is now good enough that you can hear all the little noises, including noises outdoors. I'm commenting these out so that I can see what the maximum levels are likely to be. And then I can just make up numbers. Like they shouldn't even have to be primes. They could be, but they shouldn't have to be. One thing I could do, however, is go from here. Like I think, yeah, A was 79. Your friend Soup just disappeared. Yup. So I can probably go up to about 81 here. So the sequence I'm going to try to do this feed-forward arrangement with the maximum dispersion is shortest ones in the top column, medium ones to the longest ones down here. So that means that longest one I have on tap in the final one is 47. So which is you know what? That's actually not how I should do it. Hang on. The way I've got this arranged, I have some of these organized so that the larger number is on top. So what I should do is have the smaller number be on bottom. It'll be the same functionally, but it's clearly better. So and the longest tap that I have available anyhow, let's just have it be the one that was there. 79 and 43. Now what I'm going to do going forwards is make these ones elsewhere in the arrangement much littler rather than just a little bit littler. Like instead of, let's grab a calculator and just do it mathematically, shall we? Or maybe I can do it by square roots. That might be good. 483, square root of that is 6. Let me just take the smallest prime off of the bottom there. And it's a little wacky, but whatever. And then we'll just have that. Or maybe that's what I should be doing the whole time through. 3, so 22. Eek, delete, undo. It's 80, so half of that would be like 40. This might not be perfect, but at least I'll be able to demonstrate the principle. 61, half of that be 30, half of that 15, half of that is more like 7, we'll call it 8. Okay, so all of these new delay times are shorter than the maximum range, and they're arranged super differently than they were before. They're doing the thing where rather than all the delay times being about the same and all turning into one big echo, they should disperse like this without any feedback being applied. Now we could still fool with applying feedback. I'll do that in a minute, but for now, let's hear what it sounds like with the feed-forward algorithm. But this time, the delay times are much different. But they're not all prime numbers too, so there's that. Forward verb. And there you have a delay that's still kind of feeling like, this does actually still kind of feel like it's a echo tap in there. But there's a lot more going on. Make it a lot shorter. So there's an echoey thing going on there. This is not as dispersed as I would have liked. But the idea with this, it's not so much making an infinite reverb thing going on. What we're shooting for here, and bear in mind some of these delays are so short that we could make some of the delays very long if it would help. We want to be able to make it so that, here, let's get out of this and load something like a drum track. Here's something we can use. I'm definitely a fan of Pink Floyd. I grew up on them, in fact. Different sound. What we're shooting for with this feed-forward thing is make a room-like sound where it sounds like there's stuff off in the distance. And it should sound like an echo. Now, that might not sound that much like an echo, but an echo is usually not full volume. Like, this is literal full volume echo. And it would be a fairly large room. So the idea here is being able to set it up in such a way where using this feed-forward arrangement, you got a slapback that sounds like it's coming off of a nearby wall. Now this is a cool sounding delay, all things considered. That said, I gotta say I'm not that happy with it because we are still in a zone where like the feed forward stuff is still all lining up too closely with each other. So even though that does kind of sound cool, that's not what I was after. So it's time to dive back into the code and figure out what I need to do to make it be what I was looking for. Again, I, J, K, and L, A, B, C, and D, and E, F, G, and H are one kind of stack of reverb matrices. They're in parallel. So the first set feeds everything in the second set, which feeds everything in the third set, which feeds the output. And what I'm working on with this is trying to get it so that this slightly dispersed sound becomes a very dispersed sound. Maybe I need to just exaggerate the intensity of this even more. Like I, A, and E are the long ones, clearly, so that seems about right. I'm thinking maybe some of these other ones are just not short enough. As I can stretch it out, but I'm not getting an instant slapback off of anything. And I should be getting an instant slapback coming off of some of these because there is a path through the algorithm from the bottom slot of each one that is as quick as possible. Like if I made delay L, delay D, and delay H as quick as possible, it should give me an almost instant echo, which would contrast with the longer echo that I'm getting off of the top lane. It's kind of like in, God, what's that online video game that they have competitions for where there's lanes? They're going either through the top of the forest or through the middle or through the bottom to fight the other guys. Well, we've got 4 lanes, but they all cross over constantly. And I'm looking to maximize what happens coming through the fastest of the lanes. So let's experiment with that further. We're going to do the delay thing again, but this time I'm going to look for the square root of that to give me some of these. So square root of that is like 7. And we'll call that 3. We'll call the fastest lane 1 always. Perhaps not optimal, but we'll see what we can make out of it. Square root of 79. We're going to call that like 9. And then that's going to be 3. I'm trying to get it so that I have my long echo, but then there's going to be a faster one, because I want more of a time dispersion among these. It's supposed to be feed forward. It's supposed to spread. So I'm clearly not using the right kinds of time constants. So we'll call that 8 and call that 3 as well. So now many of these delay tanks are much quicker than they were before. What I should be getting is I should be able to set up the delay to be really long, but also have a louder, sooner delay happening, not just only the one spread out long delay. Ideally, I'd like a quicker delay and then the occasional little additional echoes afterwards. Let's see what we got. That might be what we're talking about. I don't know. I don't know, I feel a little disappointed with this. This is not doing what I thought it would. We got debugging time going on because I feel like it's not doing what it's supposed to. And you know, there's something that I can do to find out right away. I can try to break it and see if it does what I thought it would do. So let's break it. All the delays are now 1. What do? This should be basically just a slapback, and I shouldn't be able to make it be a long delay unless something is wrong. And I do have the pre-delay in there, and that might be part of what's going on here that's throwing me. But for now, we're going to try the broken version and see if it does what we think it does. Because that should no longer have any significant amount of delay on it anymore. We're learning something. It feels like a lot of this was coming from the pre-delay. Like that feels about the same as we had before. There was a blur, but that feels a lot like what we had before. So that tells me it's time to get rid of that pre-delay and see what we get. Because it's all very well that be it, like that's a delay of 29. But it's distracting. Take that out. Now we should get just a total. We're kind of going back in and experimenting from the beginning because the pre-delay was distracting. It was overly, it was masking everything else we were trying to figure out. So well, that's kind of cool, but I didn't expect that at all. Are we like defining the delay somewhere else? Yeah, we were telling all the delays to be 1. This is not what we were getting at all. So the other part of this is that where, oh, there's another truck, where we were setting this, you see, I was making a mistake. This didn't do anything. Check this out. IJKL, all of this stuff, this is only setting this as a beginning factor, but when we move that delay timer thing, this is what was causing the things that we're trying to change. So we need to do what we were doing before, including paste this up here. But all the changes we just made were overridden by the fact that we just rewrote it from here. So sorry for the momentary waste of time there, but it's kind of, now I'm sad I deleted the stuff that I was using because I had figured out how I wanted to do it. But on the bright side, now this explains why I wasn't getting what I thought. So let's quickly go and make notes of our original settings, which also constitutes the longest echoes we can put in these without recoding it. 79, oh, hang on. 73, 71, 67, and see, that's what this kind of thing is like. You forget something like that and you go, why didn't it do that? And so what I was trying to do to make sense of it was like, okay, let's code them all to be the same thing. They should all act the same. And let's get rid of that pre-delay. When I still was getting something happening, I knew I had to look elsewhere, and I found this. And this is, of course, why none of the changes I was making did anything. So back to this arrangement. Now we're going to actually be able to change stuff and have it do something. And we're going to be able to do a crude version of this density spreading rather than just using this. Because what this is doing is having the most densely packed reverb echo. And we don't want that. So our longest one is going to be let's literally have all of those be 1 or something much like it. And then let's sort of interpolate, make them be halvesies, like 21, 10, and 1. 80, so half of that would be like 40. I think I probably don't need them all to be 1, so let's continue sort of having things. This should at least do what I intended. Like the top lane is the longest delay. The bottom lane is the tiniest delay, so it should spread out nicely now if all this works. And that'll be a good way to sort of, if we get this and then we're able to tweak it a little bit, it'll be a nice way of finishing off the stream, is fooling with that. Although I do have an even fancier way of finishing off the stream, but I'll get to that in a moment. 60 to 30 to 15 to about 7. And we don't have the pre-delay anymore. And we can build. So remember, what we were hearing was also the same feed-forward delay matrix. It was just with the banks of delays being very close in timing. With a bit of luck, this should be very different. There you have it. It is a feed-forward delay matrix that's sounding like an all-pass filter or something. Or Phil Collins. And the way this is being made is we've got these little banks of delays, and any given sound will go through like one of these, and then everything going through one of these will go through all of those, and then everything coming from one of those will go through all of those, and so on. So what we've got is 12 little delays makes this. And the reason it's gating is because this is not feedback. It completely and totally stops once the longest delay has expired. I also worked out stuff where you could make the tail be different by having the longest delay tap. Like if each of them doubled, you'd wind up with the longest delay tap being like way after everything else, and it would be very dense towards the front, which is not how householder matrices normally work. Normally householder matrices, they're sparse towards the front and dense towards the end. This is not that way. So there you have it. We have a nice little feed-forward delay tank. And one thing about it is this does not have the tone that you get out of a, and I haven't even picked prime numbers for this either. It doesn't have the tone that you get out of a feedback householder matrix that's like the constants are too small. And that's because even if the delays overlap a little bit, it's not feeding it back and forth through the same delay tank over and over again. Although I could put in a feedback parameter in there somewhere, but in fact now I'm curious. Now I should. Let's go and find out. Because remember, we had this bit at the end where it was like we have feedback E, F, G, and H. We just didn't use it. And those are being saved, I believe. Yeah, I think so. Let's see if it's up here. Yep, those are being saved. And that means they're still there when we go back into the beginning again. So let's see. E, F, G, H are the ones I want, not I, J, K, L. And all I got to do is just Now, shall we see whether this just blows up or acts like a proper householder matrix? Let's see what it does, because we could multiply this by something. In fact, we're going to get ready to do exactly that. There, we will be able to control that later. For now, not interested. I want to hear what it sounds like when blowing up, so we're going to find out what it sounds like when blowing up. Might have to turn down. Ah, what the heck? Turn down for what? We're not going to turn down. Brace yourself. Boom. Okay, it's still kind of like a householder matrix. I would say this is not bad. It's even dying away very faintly, probably because of the speed and vibrato. No, probably because I have a damping factor in. You know what, that's doing a thing, but if I have the damping factor, let's use it where it belongs. Where are we putting in damping? Oh, okay. See, what's going on here is this times regen does not belong where I have it. It belongs up here and only up here. All that's happening... Well, I screwed that one up, didn't I? Regen is the word I wanted. All that's happening when I do that is I still have that parameter, but rather than doing feedback in any way, it was only just turning down the total output of everything as it went from stage to stage. So it was just nothing but a volume control on all the stages. And that did succeed in turning down the feedback, but that wasn't what I was after. So we're going to take it out. We're going to take it out here, and if we find it again, we're going to take it out again. So yeah, it belongs there, not here, not here. The feed-forward algorithm does not want you to put a regen on the way it passes audio from section to section. We can always assume that we want to pass all the audio from section to section. Do we have more? Yes, we do. So we're taking full volume, and only at the point of actual feedback are we using regen. And that might give us a very nice result right away, which would be kind of cool. We're getting together something that I could just damn well compile it and give it to people, and it would work out nicely for you. Let's see, let's close this. Copy this over here. Let's go back to the same drums we had before and see where we get. I wasn't expecting it to work that well first off. Did I say work that well? That counts as not working that well. Let's put some damping in. 100% damping should... did I say should? Maybe I misstated myself. Okay, let's find out why damping isn't working. This is more what I was expecting. You heard that? That was more what I was expecting to happen when first experimenting with this idea. What have we here? Why is it doing that thing? I'm sure it's down to this. It's down to having the feedback. I should be able to put it regen equals 0, and it'll be back to behaving nicely again. It should. The question is, oh, I see. Regen, depth factor, blah-de-blah-de, that's much more complicated, and I need to be able to take it literally down to nothing. Let's get rid of that stuff, and we'll go for straight up regen equals get parameter kparam2. It will go between 0 and 1. 0 is nothing. Now if I compile this, I should be able to get something that acts like it did before, and then we can experiment with how much of that it can handle as feedback, because it might not be able to handle any of it as feedback. Let's see. Have we got another terrible explosion? All wet. Damping 0. Okay, that's normal. That's what we wanted. How much of this damping makes it go insane? Wow, very little? Oh my god. Like 0.1 is enough and it just explodes. It's pretty impressive, I gotta say. What's 1 divided by 64? 1 divided by 64 equals 0.015. Okay, so it's not that. There's going to be a magic number in here that is 100% feedback, and it's not 1. 1 makes everything blow up violently. Five. I think we have infinite sustain. 0.125. That's what we're looking for 100% infinite reverb. It's kind of cool. So the next thing I'm going to do is hard code that into regen. Times 0.125. Because that is our ultimate infinite feedback setting right there. And since we're not using depth factor, we're not using depth factor. Let's build again, and so now that we've got a variety of stuff going on, we've got, again, there's our little drum thingy. Forward verb. Dampen can be nothing. We've got a kind of stone room effect. We can change room size. We can make it tiny. And we can add this damping. Nothing going on with flavor, we can remove that. And speed and vibrato do still work, but they're probably less important than they were in matrix verb because of the way this is arranged. Good old golden ratio. And this is without the time constants tuned at all. So yeah, this has been the process of experimenting with a feed forward rather than a feedback reverb. I gotta say I'm pleased. I'm pleased with how this worked out. I think this actually kicks the butt of matrix verb. Although matrix verb has its place as far as things that sound less natural and more like reverb box stuff. But I gotta say, like, this kind of craziness is all very well and good. And then as we start getting into the feedback over several stages of it, it's like our initial stage is workable. And I haven't even tuned the timing of it either. We start bringing in, we hit that golden ratio point. And I feel like that happens to be a very convincing big acoustic space. Like the way that it feeds back in again. I don't even have any filtering or anything yet. Seems good. Seems good. I hope I haven't lost people off of the scroll on live chat. I think I probably just don't have anybody, which is all good. It's fine. The important thing is I figured this stuff out. Just a little bit of shaping to this algorithm. And it can probably do a very nice job of being a plausible space. Yeah, that's fine. %, is about as loud as you can get this so that you still have to have a dry in there. It ends up being just about like infinite there. Except for this is infinite. I would call that a good day of work. Let's call that a good day of work. I have some very clear ideas about where I can take this, but we can catch up with that perhaps next week. We've been doing explorations into reverbs over multiple weeks, so I can get back into this and we'll see where we can take it. Again, I suspect I don't need to do the pitch bending stuff that I was doing with the matrix verb to make this work. It feels as if it's going to be fine with just delays. And that's consistent with what Casey from Bacasti, that's the name I was trying to remember before, what Casey from Bacasti was saying when he was talking about stuff like that. One of the things he says is pitch bend in algorithmic reverb, pitch bend in reverb algorithms is garbage and should never happen. He says pitch never bends in reality. And I don't think that's necessarily quite true. I feel like the way it works, if you're going through temperature differentials, it's like seeing heat waves coming off of a highway or something like that. You're going to get fluctuations and modulations, and those will take place having to do with pitch because that's how they're going to be perceived. You don't get a consistent pitch bend, but you'll get a waver. And I think that's where that comes from. But it seems like using the feedforward stuff, you kind of don't need it. It seems like using the feedforward stuff, you can get way big without having to go for pitch irregularities to get out of that feedback householder matrix type stuff where it's this very continuous wash of noise. So yeah, I'll catch up with you guys later. This has been a good work day. Let me close chat. Wasn't doing much even while it was there. And yeah, I'll talk to you folks later. It's going to be fun looking back on this and like listening back to it and hearing, because I have not heard this yet. You've heard it, I have not. I have not heard what the lav mic sounds like through the preamplifier into the 16A and then patched straight through to the stream. I'm delighted that it works, but I'm looking forward to hearing what it actually did because I've never heard that. So we'll see. We'll see whether it sounds good. The bigger mic sounded okay on Sunday, I thought. Maybe not quite as glossy as it does run through the fancy mixing board, but you know, it was cleaner. And since it's coming into a mix in Logic, I could put stuff on it to gloss it up if I wanted. But anyway, that'll do. Talk to you later. Bye-bye.